Hi everybody, let's talk about sedimentary rocks. Now, sedimentary rocks are made of sediments. What are sediments? Sediments is sand, gravel, silt, clay, boulders. You can even include in on that shells and wood and bones and any bits of little animals and plants and things. And it's all this stuff that washes downslope or travels downslope through erosion and deposition. And it's going to travel downslope with glaciers and gravity and wind and running water, and it's going to move around with waves. And eventually, it's going to build up somewhere, and it's going to get enough materials on top of it that pressure is going to glue the molecules or the rock pieces together. So you're going to get cementation or compaction and cementation. So when we look at sedimentary rocks, there are two main classifications. There is clastic, which is made up of pieces, and there is non-clastic, which is made up of organic means such as shells or plants, or it is made through chemical process. So we're going to go through, we're going to start, and we're going to talk about clastic. And with clastic, whenever we get into, or if we were to do our mineral lab, the first thing with plastic that you've got to figure out is what are the size of the particles that make it up. Are they larger than sand-sized particles? Are they sand-sized particles? Or are they smaller than sand-sized? If they are larger than sand-sized, and we've got a couple examples here, and I'm not going to give you the names of these rocks. I am just going to put the rocks in here and show you and talk about them. So if they are larger than sand-sized, now we've got to look at the shape. Are they rounded particles? Are the fragments in here? And when we talk about the larger than sand-sized, that's going to be the large ones. And then they're glued together by other particles. In this one, it's a little tougher to tell, but this is a particle, and this is a particle, and this is a particle. So they're all large particles in here that are cemented together by something else. So are they rounded like this, or are they angular like this, not rounded off? Okay, so if you have a larger than sand sized, you're looking at, are they rounded or are they angular? And I will tell you that this particular piece, this is a really common rock in the northern part of the state, up around Kinzu and Tionesta and that area. Okay, if they are sand-sized, so I'll try and show them to you best as you can. So here is sand-sized particles, and it's exactly that. It looks kind of like you take a handful of sand and you clump it together. Now, some sand is a little bit coarse, some sand is fine. They're still within that range to make them sand-sized. So now we can even look at color. This is a quartzish. This is made up primarily of quartz. This has that sandy look, while this has a reddish look to it. It depends on what rocks broke down and were carried away to make these rocks. Because that's one of the things with sedimentary rocks is they are made up, especially the clastic ones, they are made up of pieces of hundreds, thousands, millions of rocks that have all washed down slope. If you think about the rocks in this area, when they weather and they erode and they get swept down into our streams and down into the Yaak, and then from the Yaak to the Mon, and the Mon to the Ohio, and the Ohio to the Mississippi, where they get washed out to the Gulf of Mexico, all of the rocks from almost half the United States all end up down into the Gulf of Mexico through the Mississippi. So millions and millions of areas of rock that all get washed down to become this. All right. Then if you have a smaller than sand size, this is going to be clay and silt. And now you're looking at this. This is smaller than sand size particles. The problem with this is you can't see the particles because they're so tiny, but they are in there. So you're looking at the shape of this one. This one tends to break off in thin sheets like this. All right. Now, if they're non-clastic, then non-clastic means they have some other type of origin than just broken up pieces of other rocks. An example would be this. This is made up of broken up pieces of seashell. I know it kind of looks like a granola bar or an oatmeal bar, but it's actually made up of pieces of shell. In fact, there's a piece that just broke off. All right, we have this one, and I don't know if you can see this one too well. This one is just this black rock. It kind of breaks off into little pieces. This is extremely common around here, and this whole area was built on this. This is made from dead plant material in swamps that has fallen and piled on top of each other, and it's just continued to squeeze and squeeze and squeeze and squeeze until what you have left is the carbon, and that's this rock. All right, and then the last one is one that can be formed through chemicals, through what is known as, and I'm blanking on the term right now, it would be in solution, and it would precipitate. That's the one I wanted to find. It would precipitate out of solution, and it would settle on the bottom of the ocean and then get covered and get pressed and turn into this particular rock. All right, so we need to embed a couple questions in here in order to ask you guys these things. So in a sedimentary rock, you have clastic and non-clastic. And if you have clastic, which is made up of pieces of other rocks, the very first thing you want to do is look at what? What's the first thing that you want to do? The difference between this rock and this rock and that rock. And that should be a big hint for you. But let's pause this and ask the question now. All right. If you are looking at these two rocks, okay, the particles in one compared to the particles in the other, let's call this one A. The particles in A are what shape? The particles in B are what shape? All right. All right. I will talk to you guys later. Take care. That is Sedimentary Rocks.